All right, so this video is for section R5, which is dealing with rational expressions. We've broken this section into two parts. So this first part we're calling R5.1, and we're dealing with really multiplying and or dividing rational expressions. So we have a rational expression or a polynomial over a polynomial, which makes a rational expression. Here what we're doing is we are dividing one rational expression by another. And we'll talk about that when we come to it. But you'll notice here that there are plus signs between, right? So it's not a monomial over a monomial, or even a polynomial divided by a monomial, which we did in the previous section, all right, when we did, I think, R3. Here, we've got a polynomial divided by a polynomial. So, for example, I'm not going to be able to just cancel this a cubed with this a cubed. I cannot cancel part of a polynomial with part of a polynomial. I've got to cancel, I can only cancel when things are being multiplied together, not when they're being added together. All right. So what we have to do is really factor first. Now it says find the domain, but we'll get to that when we factor. So factor the top and factor the bottom. So what is the GCF on top? And the GCF on top is a cubed. So I'm going to take an a cubed out of the top, and that gives me 3 plus a. And then I'm going to factor the bottom. In this case, I'm going to take out a GCF. And that GCF appears to be what? 2a squared. And what's left after I take a 2a squared out of that is an a. And then we have plus 3. Okay. Now, think about what the domain is. And by factoring specifically the denominator, when we say what's the domain, we really are looking at the domain is like what values of a could we put into this thing, right? And so really sometimes when we're looking for the domain, it's not so much what can be put in, but what cannot. So when we talk about domain, we often think about, well, a can take on any value except what? And so in this case, because we're dealing with rational expressions, we know denominators cannot be 0. So we can't know that this part cannot be 0, nor could this part be 0. And so what a value would make this monomial in the denominator 0, and that value would be 0, right? So what value would make this part of the denominator 0? And so an a value of 0 would make this 0, and then 0 times anything would be 0. So a cannot equal 0, but then also over here, a cannot equal a negative 3. So those two things make up the domain. Right? So we say, we have fancy ways of saying it, and we'll say something like the domain is any x value such that x cannot equal 0 and x cannot equal negative 3. That's a fancy way of doing it. The domain, that's supposed to be a D. The domain is any x value such that x cannot equal 3 and not equal negative 3 and 0. So we're interested often in the domain. We're really looking at what values can the variable take on. But in this case, we're really more concerned about what values it cannot take on. So it can be anything. X can take on any value such that it's not those two. Okay, so it's like all real numbers except not 0 and not negative 3. All right, but let's continue and let's simplify this because that's really what we're trying to do. Notice this binomial and this binomial are really the same because of the commutative property of addition. A plus 3 and 3 plus a are the same. So I could cancel this and this out. And now listen, I can also cancel out some a squares, right? So I cancel out an a squared here, and this becomes a 1. And so really what's the final answer, the simplified version of all this, that all simplifies down to a over 2. Okay, so you just have to be careful. You can't cancel like this a squared with this a squared. Like you can't turn that to an a squared and like make this go away. That doesn't work. We can't cancel out parts of binomials. So you got to factor everything first, cancel out things, because now this is getting multiplied and this is getting multiplied, right? So this monomial times this binomial times this binomial. Now I can cancel out entire binomials. But I can't cancel out parts of things. Okay, let's move on to the next one. Number 2, and you might try some of these on your own. Pause the video, see if you can do them on your own. You want to factor everything and turn this into multiplication. So trinomial, we're going to factor that. That's going to be, 2 binomials. And this is going to factor as well into 2 binomials. And then we're going to multiply. We're going to keep, change, and flip, right? We're going to keep this a factored form, but no, don't switch it, times and then the reciprocal. So instead of dividing by a fraction, we multiply by the reciprocal, but let's factor it. So this thing becomes x minus 2 on the bottom, factor a 3 out, x plus 1. So that's what became over here. Instead of division, we turned it into multiplication and we do it by the reciprocal. And then factor this up top. I know it's going to be x and x. Factors that are 8, the difference should be 2, so that should be 4 and 2. The 4 should be positive because this is positive, all right? And so that's how those two factor. The bottom, that's going to be x and x. Factors that are 3 that have a sum of 4, that's 3 and 1, have a sum of 4. They're both positive. I know they're both the same because of this plus sign, and that means I know that the sum of the two things should be 4. Okay, and now it's a fraction, right? A fraction times a fraction, but really I can think of it, now that I turned it into a fraction, I can think of it as one big fraction, and there are multiplication dots between all these things, right? Between these binomials and coefficients, it's all multiplying. So now I can cancel anything upstairs with anything downstairs. So I can cancel this x plus 2 with this entire x plus 2, right? Because there's implied parentheses here. All right, so x minus 2 and x minus 2 cancel. X plus 1 and x plus 1 cancels. Notice I'm not canceling out x with an x, right? I'm not canceling this 3 with this 3. Can't do that. All right, so what's left on top is we have 3 times the quantity of x plus 4. And then I have x plus 3 on the bottom. Okay, now we really want to simplify everything, so generally we want to get rid of those parentheses. So make sure nothing else cancels, and so I think as the best final answer we'll say 3x plus 12 over x plus 3. And notice this 12 and this 3 can't cancel. This 3 and this 3 can't cancel. We cannot cancel parts of binomials with other parts of binomials. The whole binomial, like we did over here, x plus 1 can cancel with this x plus 1, but I can't cancel this 12 with this 3. That doesn't work. Oh, got a little spider crawling on my... Let's get rid of him. Okay. Sorry, I'm down in my basement recording this, so occasionally I see a spider. Okay, so that is our final answer. All right, good. All right, let's go on to this one. Now, this one's already factored. It's monomials times monomials. So I can cancel anything upstairs with anything downstairs. Notice there were plus signs here. I essentially gave you the same variables, but notice this was a binomial up here. This is really just a monomial. There's multiplication between them all. So it's all one big monomial, one big monomial. So now I can cancel anything I want with anything, upstairs with anything downstairs. So a 6, I can take a 3 out of the 3 and the 6, right? So those become a 1 and a 2. I can cancel this a cubed with this a cubed. I can cancel the a squared with the a squared that's in the a to the 4th. So a squared and this becomes a 2, a squared. All right, so after you cancel a bunch of stuff, if you want, we can really just write out, all right, what's left upstairs? I have a 1, and I have an a squared, so I'm just going to say a squared. And then what's left on the bottom? I have a 2, this a cubed went away, this a squared went away, so really just 4. Okay, and nothing else cancels with that. Oh, we forgot to talk about the domain on number 2. So the domain, so x can't take on a negative 1. So x cannot equal negative 1. X cannot equal negative 3. It cannot be, x cannot equal 2. But also, this x plus 1 was really in the bottom of the original problem, right? The denominator of this fraction. So really, that also limits. This cannot equal 0 because the original problem would be undefined. The fraction we're dividing by would be undefined. So x can also not equal negative 1. All right, and then just check in your answer, make sure negative 3 would be bad. That's it. So we can't, it's not just the answer that is the domain we're looking for. That would be x cannot equal negative 3. That would make our answer undefined. But it's the original problem as well. So any fraction in the denominators or in the denominator of the original problem, all of those things have to be eliminated. So x cannot equal, well, I already had negative 1 from down here, so I wouldn't have to duplicate that one again. But it's, this can't be 0. This whole thing can't be 0. And because we flipped it, this bottom part, this also can't be 0. So we got to concern ourselves with all of those. And this one, I guess, the only thing that would make this original problem undefined would be a equals 0. So the domain for this one would be that a cannot equal 0. Even though that doesn't apply here, it did apply. It would have made our original problem undefined. Okay. So anything that makes, in this case, anything that makes this denominator undefined. So let's factor this, and that's going to help us figure out what the domain would be. So binomial upstairs, let's take out common denominator. So that's going to, looks like we'll take out a 2x, and that will leave us with 2x minus 1. And then let's factor out the bottom. So when you first look at this, it looks like you would factor out a 3x. So if I take out a 3x, notice I'll get 1 minus 2x. Now, these two binomials, like up here we had 3, on number 1, we had 3 plus a, and we had a plus 3. We could just cancel those out. But we can't cancel these two out. They're not exactly the same. 2x minus 1 and 1 minus 2x are not identical. So the commutative property of subtraction does not apply. There is no such thing. So I can't just cancel these out. So what you really want to probably do here is think about, like they're almost the same, but if I had factored instead of 3x, if I had factored a negative 3x, we talked about this the other day in factoring. We normally don't think about factoring a negative out, but sometimes it's helpful. So if I factored a negative out instead, then I would have a negative 1 and a plus 3x. Now these are sort of flipped around, but you can hopefully see that these are the same. These two binomials are now the same. 2x minus 1 and negative 1 plus 2x are identical. They really originally differed by a negative sign. And so we factored that negative out, negative 3 out instead of just a 3, and it changed the signs of these things. Now I can cancel these. Okay, so you can see it made our result negative by factoring that out. All right, and then we can cancel out an x with an x. So really, this reduces down to just negative 2 over 3. However, we have to think about our domain, and the domain for the original thing here, x, for the domain here, x cannot equal 0. And what would have made this 0? You know, if you have a hard time seeing that, you can set this. You can do a little side problem and say, -1 plus 2x equals 0. Set that equal to 0 and then solve for x. So that would be x cannot equal 1/2 would be the other one, right? I mean, if you solve for this, it would be x equals 1/2. Bring the 1 over, divide by 2, so x would be equal to 1/2 is what would make this 0, which is bad. So x cannot equal 1/2. I mean, if you want to think of this as just x equals 0 is the solution by setting that equal to 0 and solve it, x equals 1/2. But that really means x cannot equal 1/2. It would be because we're looking for what x can't be. What x value would make this 0, and that is 1/2, and so it can't be 1/2. Okay. All right, moving on to a couple more complicated ones. Number 5. Again, what we want to do is we want to factor this stuff. Hopefully you remember your difference of cubes that we learned in R5, so that's going to factor. And then these are these are 4-term polynomials. Those are also, looks like they're going to factor, probably by grouping. All right, so let's try that. If you want, pause the video and then come back and see if you did it right. All right, so at the top, we're going to factor, that's going to be a binomial times a trinomial. I'm starting over to the left as far as I can because I'm going to need this space. So that's going to be x. Let's do our signs first. So it's the same, it's the opposite, and it's always positive. So it's going to be x, it's going to be y, it's going to be x squared, it's going to be xy, and then it's going to be y squared. All right, on the bottom, we have the difference of two squares. So that's going to be two binomials. It's going to be x plus y and x minus y. Again, that doesn't matter what order you put those two binomials in. I just do my plus first, then my minus. All right, times now. Let's see what's going on with these. And I might just do a little bit of pre-factoring up here so that I can kind of have my factored form here. So what am I taking out of these? I'm taking a 2 out of the first, so x plus y. And I'm taking a z out of these, so that's x plus y. And this way here I can just write it final factored form. So we have x plus y, and we have 2 plus, that's a 2 plus a z. Now I write my z's with a little line between them to differentiate because that 2 could look like a z. My z's always have lines through them, so you can differentiate them between 2's. Okay, on the bottom, let's see, what are we going to take out of this? We're going to take out a 2, so that leaves us with x squared plus y. And then I'm going to take a z out of these, similar to what we just did, x squared plus y squared. And so you can see my, oops, I lost my square here. You can see my binomials are the same here in the parentheses. So this is going to be x squared plus y squared. And then 2 plus z. Okay, so everything, it's multiplication, so we're ready. Everything is factored. We can start canceling things out. So I can cancel my 2 plus z with my 2 plus z. Let's see, what else can I cancel? I can cancel my x plus y with my x plus y. I can cancel my x minus y with my x minus y. All right, so let's rewrite what we have. We have x squared plus xy plus y squared over x squared plus y squared. Now remember too that this looks kind of like a perfect square trinomial, but it's not. Remember, it had to be a 2xy for this to be a perfect square trinomial, and it's not. So this is not factorable. And remember too that I cannot cancel my x squared with my x squared and my y squared with my y squared. Students want to try to do that all the time, but remember that plus sign keeps us from being able to cancel these two things. This plus sign keeps us from canceling these. Cannot cancel part of a polynomial with part of a polynomial. It doesn't work. Okay, so that's it. That's as far as we can go. All right, and so the domain, yes, okay. We're really more concerned about the domain when we only have one variable. And so here we have x's and y's, so we're not going to be so concerned about the domain. Domain is really more of an issue really when we're trying to solve an equation. Here we're just simplifying them, but it's a good to start thinking about it, but let's not worry about it on number 5 because we have 2 variables. So let's not worry about it. Okay. Number 6. All right, so we have, we're going to want to factor this stuff, and then also we're going to want to turn that into multiplication. So while we're doing that, and then also think about taking out GCF. So I'm going to take my GCFs out first. So we have 15, and then that's going to be 3 minus x. I'm just going to do a pre-factoring before I kind of rewrite it. I'm going to factor 4 out of this on the bottom. That's going to be what? X minus 3, right? And then no GCF here, no GCF here. So we want to factor these things. But I think you might see that we'll have a hard time factoring this trinomial. Let's factor a negative out, because we're going to rewrite this with x squared first, but it has a negative. So I'm going to factor a negative out and rewrite it. So it's x squared minus x minus 6. So everybody see what I did there? Because we can now factor this trinomial. We'd have a harder time factoring this trinomial. It's in a weird order, but also the leading coefficient, x squared, has a negative, and we don't want that. So I factored a negative out and rewrote it. So everybody hopefully see that these are the same thing. Okay, so I've done a little pre-factoring next to each one. This one here, I'm just going to factor as a normal trinomial, and I'm going to do that down here. So factor it into 2 binomials. So I'm going to say 5x and x, so that I get a 5x squared. 3, let's see, do I want my 3 here, or do I want my 3 here? Let's see, I'm trying to think if this actually factors. This seems like it's not going to factor. If I put a 3 here, yeah, I don't think that factors. This, I'm having a mental block here. If I put a 3 here and a 1 here, that's 15 and 1. That doesn't give us that. And if we put a 3 here and a 1 here, that doesn't give us that. So that's not factorable. I'm wondering why it seems like that should be factorable. I'm going to see if I somehow did a typo or something. Oh, yeah, there's a typo in this. This should be 30. That's what it is. There should be a 30 there. I don't know if on your paper it's a 30. Somehow when I do equations, sometimes things get dropped. So okay, so that should be a 30. All right, so now it's factorable, right? Well, probably it's more likely to be factorable. So 30, that's either going to be a 3 and a 10, or a 30 and a 1, or a 6 and a 5. If we do a 6 and a 5, oh, actually, okay, because it's a 30, now that's different. Now we should have taken a GCF out. Yep, that's it. So take a 5 out. That leaves us with x squared. Take a GCF, or I'm going to do a little pre-factoring up here. So we have a 5x minus x minus 6. Okay, that's much nicer. All right. Oh, and now that I look at it, notice these are the same. So I'm actually not going to factor those two, because the whole trinomial is going to factor once we do the flip thing. All right, so let's not factor that thing. Let's leave it alone. So we have 5, x squared minus x minus 6. And then on the bottom, we factored a 15 out, right? So 15, 3 minus x. Now notice, too, that this x minus 3 is going to get flipped. Let's do that right now. Hang on, before we finish talking about this down here. So it's going to be a 4x minus 3 upstairs. On the bottom, we're going to get negative x squared minus x minus 6. Now, it would also be nice if we could get these things the same, right? We have x minus 3 here. If I factored out a negative 15, like I only did a 15 up here and got 3 minus x, but I have x minus 3 here. So if we want to cancel these two, because this one's going to flip upstairs into the numerator, so I want to take a negative out. So let's rewrite this. Instead of 3 minus x, it's going to be positive x and a minus 3. Okay, does that make sense? Now we can cancel these. So when you see that they weren't conjugates of each other, right? 3 minus x and x minus 3 aren't conjugates. What they are is they're the negatives of each other. And so if you take a negative out, you could have taken a negative out of the 4 and said 3 minus x, and then these would have canceled. But one way or the other, you want to take a negative out of one of those. So the x minus 3 is now cancel, and this whole trinomial cancels with this whole trinomial. But don't forget about your negative. That's essentially a negative 1 out in front. 15 and 5, that would cancel. We have negative 3 down there, right? The negative goes with it. All right, so this really all simplifies down to, we have a 4 over a negative 3. Now, often we'll not want the negative downstairs. It's more proper to really say negative 4/3, but either way. Some teachers will be upset if you leave the negative downstairs. I don't care so much about it, but so definitely negative 4/3 would be better. But anyway, all right, let's go on to number 7. So again, we want to do some factoring, look for GCFs. If there were any GCFs, I would do a little pre-factoring above and below, but I don't see any GCFs in here, so we're just going to have to dive in and just start some factoring. On the bottom, it's just going to be x plus 1, and then we're going to multiply, so we'll flip these, right? So, all right, so we're going to have 2x and x. At 9, so I'm going to probably guess that it's going to be the 3 and the 3. So let's see, the signs are the same. They're both positive. Let's put those in. And let's check these. We have 6x and we have 3x. That's 9x in the center here, so that works. All right, let's try these. And again, remember, we're flipping them. So let's factor this one upstairs. The one that's downstairs is going to be upstairs. So 5x and x. And 2 and 1. So do I want the 2 to get multiplied by the 5 or the 1 to get multiplied by the 5? Remember, the center term is 7, so I want the product of those two to be 7x. So I don't want the 2 times the 5. I want the 2 here. 2 and 1, so that's 5x and 2x, which gives me the 7x in the middle. Both are the same sign, and they're both positive. All right, this one, 2 binomials. This is now the top that got moved down to the bottom because remember we're doing the keep change flip. Instead of dividing by a fraction, we multiplied by the reciprocal. So this will be, it could be 10x and 2x, 10x and x, but it'll probably be 5x and 2x. Because often with these types of problems, we want things to cancel. So I'm going to guess that there's a 5x here, a 5x here. There's a good chance that this is going to be x plus 2 here. But let's see. All right, so we have 6. So let's assume it's going to be the 3 and the 2. I can't put the 2 here, so I'm going to have to put the 2 here and the 3 here. If the 2 and 3. It could be 6 and 1. We'll have to try. Let's see what we get. We get 15x, and we get 4x. So 15 and 4 is 19. They're both signs are the same, and they're both positive. So yeah, that works. All right, so let's see what we can cancel. So notice the 2x plus 3 and the 2x plus 3, those cancel. And the 5x plus 2 and the 5x plus 2 and the x plus 1 and the x plus 1. So really this all boils down to just x plus 3. All right, so we didn't talk about the domain for this one. So of course I know x for the domain, x cannot equal -1 because that would have made this denominator 0. What would have made this denominator 0? That's the stuff that's upstairs. I set each one of those equal to 0. That's going to be what? X cannot equal, if we take the 2 over, it'll be -2 over 5. Set that equal to 0. X cannot equal -1. We already have that one. But now also when we flipped it, this part can't be 0. So we already have this one. This one, if we set it equals 0, again, if you need to do it sort of on the side, if you can't do it in your head, the 3 is going to come over, right? 2x is equal to -3. The 3 becomes negative. Then we divide by 2. So x can also not equal -3/2. Okay? And I guess we didn't really look at the domain for this one up here. Again, we have to make sure that this can't be 0, which would be what? 3, right? So x for the domain for number 6, x cannot equal 3. And then, which is what this was anyway, so that's good, that takes care of that. And then this stuff down here, well, we never did factor that to figure out what it was, so if we factor that real quick, we have x and x, the different signs, so it's going to be -3 and +2. So x cannot equal, we already took care of the 3 here, but x cannot equal -2 as well. It would be the domain for that one. Okay, so just any denominator. So this is a denominator. This is a denominator in the original problem. But then as we work through the problem, this became the denominator, and so we have to check for that one too. Those could not take on those values. So often when we're concerned about the domain, it's often really about what values we can't have the variables take on, and those are often the values that make our denominator our fraction undefined, or the denominator equal to 0. All right, so your homework for the first part of R5 is listed here. 1 through 4, that's all of them, and then 12 through 48, that's just the evens, and then 49.